a boy of mass 50 kg, that's good, it's in kg, runs up a staircase of 45 steps. So there are 1, 2, 3, 45 steps. Each step is in 9 seconds. So he reaches from this point A to point B in 9 seconds. If the height of each step is 15 centimeter, so each of this is 15 centimeter. So in total, what will be the height? What is the height to which he reaches? So what should we do? We have to add, multiply, divide, subtract. Yes, we have to multiply. Multiply what with what? You have to multiply 45 with 15. So total, is it vertical or horizontal displacement? Total vertical displacement would be equal to what? Would be equal to, there are 45 steps, each are of 15 centimeter. So this would be what? 45 into 15 divided by 100 meters, because a centimeter is 1 by 100th of a meter. Right? So we'll just keep this. We won't calculate this. It's not required. 45 into 15 by 100 meters. So that's the vertical displacement. We are not talking about horizontal displacement because they're not asking us, or they have not given the required information. So we can think of the states as a roundabout. So there is no vertical displacement. Sorry, horizontal displacement is not there. Okay, again I repeat, there is no horizontal displacement. There is only vertical displacement of the kid. So this person is moved from point A to point B, and the person has a mass of 50 kg. So it's basically we doing a work of shifting a 50 kg item from point A to point B in 9 seconds to a height of 45 into 15 by 100 of a meter. Okay, so that's the whole funda. Got it? Right? Now, what else we need to, we can mention acceleration due to gravitation as 10 meter per second square. If not, we pretty much have all the data written over here. That's your given. Now we'll start with our working. So what is that they want us to find? Power. Power is work divided by time. So what is work? Well, work is force into displacement. Now, what is the force that is required over here so that the person moves up? See, one thing is the weight will be pulling him down. So the weight of the person is 50 into 10. So we know that at least we have seen all of this. Experimentally, we have seen this. So if you're not done this, if you're just seeing the numericals, you have to watch, which section is that? Derivation for potential energy. You guys have to watch that to understand this better. So we need at least 50 into 10, that is 500 Newton of force. A lot more than that won't help. Lesser than that won't help. Exactly that, a bit more than that will help. So that bit more can be approximated to 50 Newton. So we need a force of 15 Newton. Okay guys, so we have to write that, we have to express that. Now let me put it in a better manner. I'm not very happy with that. So we know the power is work by time. Work is force into displacement. The force required to displace a 50 kg person will be 50 into 10 Newton. We need to write that. We need to explain why is that we got this value. Therefore, work is equal to 50 into 10 into 45 into 15 by 100. So that's the art of not calculating things. 0, 0, 0, 0. And we have 45 into 15 into 5. Again, I'm not calculating any of this. So many job. Agree? Right? Now we have the power. We can get the power because we know the work and we know the time. And so the power, I'll do it in a separate slide. Power is equal to 45 into 15 into 5. Since we have written the formula before, so we need not write it again. Time is 9 seconds if I'm right. Right? And you can see over here things will get cancelled. That's why we should not calculate. See, the point is this is the final answer. So you need not calculate 45 into 15 and all of that. Now we can show the direct answer and we'll be done. So we can see 5s are 25, 25 into 15, 25, 250, 250, 125. I hope I'm right. 375. 375 watt. Again, if this number is wrong, you guys can calculate the right one. So my job is to show you till here. Multiplication is your job. Okay, so have you done everything? Yes, find his power. The power is the boy's power is and all of that. Again, no one will care. You just write this. You are done. Underline and you're done. Okay, guys. So the funda over here is, the main thing over here is this. This you need to understand. How we got this value is something that you need to be clear with. For that, you need to watch potential energy derivation. People have not watched. So that's where you will find this. Okay. And everything else is matter of calculation and conversion. Over here, it's conversion. Centimeter. Every centimeter is 1/100th of a meter. Centimeter is smaller than a meter. So when you're converting from a smaller to bigger, obviously we have to divide. Agree? Right? So if not, what else? Yeah, pretty much that's it. So we're not talking about the horizontal displacement over here. We're just talking about the vertical displacement. Okay. So if the horizontal displacement come into picture, the question will get a bit more complicated. Not too much, a bit more complicated. Okay, now you can pause and have a look.